So now, that's a description of the data. I think, one of the things I wanted to kind of have you see with all the different slices of the data was just how bad a model I'm about to write up is, right? I mean, the bottom line is when I sliced, just go back to these. To these tables, right? And if you remember, I have, this is, we really only have so to just reiterate what these different slices are, they have things like income sources, age, education, employment status, marital status. So, and then if I had that other stuff would have said something about, delinquent or bankrupt and all that, that would be down here as well. And the model is not going to have, in terms of age, education, employment status, marital status, all that kind of stuff, it's just not going to have a lot of these things, right? I mean, there really is only, one of the things here is business. We're not going to have entrepreneurs in it. And in fact, in the particular model I'm about to write down, I'm not even going to have transfers, taxes and transfers or anything. That's easy to put in exogenously, hard to put in endogenously, okay? But, again, I'm not going to have age, I'm not going to have education. I don't have, all I have are basically workers. They have retired. I don't have people that are disabled. And then we don't have the family status in this. Okay, so, but that's I just wanted to be upfront that those are the things that we're missing. Okay, and that's where you guys can come in and add to this literature. Okay, all right. So now now I've got to talk about the model I'm going to write down. So I'm going to kind of do this really simple. I'm actually doing a simpler version than this paper by Huggett. And so the model that I'm about to write down, the way I'm going to think about the earnings shock process, which I'm going to take as given, is going to be in terms of people being employed and unemployed. Okay, it's going to be a general equilibrium model. There's no choice of how much to work even. Okay, so it's going to be like an exchange economy. There's no capital. All that stuff you would kind of want to start to put in a model, but I'm trying to keep it as simple as possible. What's going to come out, as I say here, the equilibrium objects are the borrowing, this savings function. One of the things is going to be a savings function that comes out. I'm going to get a price that's going to come out, and then I'm going to get a cross-sectional distribution of wealth and earnings. The earnings part is basically if you integrated across the wealth stuff. So the distribution I'm going to find is going to be defined over a person's employment status and their wealth. If I integrated across wealth for a given employment status, that stuff is in some sense just exogenous because that's just given from the exogenous process on earnings. But the wealth part of it, conditioning on a person's, whether they're employed or unemployed, the wealth distribution is totally endogenous. Okay. When I said earlier that talked about the tails, from the paper that we were just talking, this Diaz Jimenez, Glover, and Rios Rule paper. One of the things, if you read that Federal Reserve Quarterly Review, they basically say, and this is kind of what the issue is, one of the hardest tasks that any theory of inequality faces, now this is their take on it, you may not have the same take, but is to account for both tails of the distribution simultaneously. Okay, so that's, we're not going to do that well on that, and that's we find as macroeconomists, and it's very hard, and that's where we're asking people to try to add to the literature. Okay, so now I've got to write down the model. Okay, so what's the model going to be? Let me just put your hands up. How many people have seen a heterogeneous agent model in their economics classes. Like, yeah, so either a paper like by Huggett or a paper by Iagari or something like that. So it's starting to become a lot more standards. The reason I'm asking that is because then it lets me decide, how fast I can go. The other part of this question is, how did you guys use that to think about inequality? I mean, how much did you use it to think about inequality? And the other question is, did you actually ever solve it? Yeah? Okay, good. So, okay, good. So I'm not gonna, don't worry, I'm gonna be talking to you here, because I'm just gonna, it's always good to see it a second time, okay? So that's what we'll do. Okay, so here's the model. There's going to be a unit. Remember, I said we're going to apply the law of large numbers. So there's going to be a continuum of households. So there's a unit measure of households. Preferences are going to be pretty darn standard. This is not in Huggett's paper, but I'm just going to assume basically that preferences are bounded. So when I write down the utility function, when I'm about to write it down, just, I wrote it down kind of loosely. Just think that, in some sense, beyond the precision of a computer, I have that utility is, bounded. Okay, technically, it's good to have bounded utility functions because then you can apply very simple theorems from, let's say, Stokey and Lucas. How many people have read Stokey and Lucas? Okay, that's a standard kind of thing too. What?
Are you ruling out stone theory?
I don't know. I mean, anything that's unbounded, I would be ruling out.
Well, again, I don't want to belabor this point. Blinder's critique of Lucas is all driven by the choice of utility function that violates your assumptions.
I mean, the bottom line is, as long as my utility function, it's going to turn, you'll see how the model works, that as long as the preferences are, in fact, in some sense concave, concavity is going to be very important. But there's the problem for existence of an equilibrium like this, when you think about, so remember, let me give the big picture again. So we're gonna get three endogenous objects, because one of them is the interest rate. We're going to get savings functions, and then we're going to have this cross-sectional distribution of wealth. The thing that's a little harder than what, in this whole thing, that, you got savings decision functions, let's say in your first semester of macro, right? You could have solved for savings rules in the stochastic growth model. That thing is just, the way we're going to get that is an application of an operator. It's going to be a contraction mapping, and that's what we apply the stuff that's in the first part of Stokey and Lucas. The hard part about this is now we have a cross-sectional wealth distribution. Now, I have a lower bound by the borrowing constraint. I have whether it's natural or not, I have a lower bound on the cross-sectional wealth distribution. The problem is, you don't want a cross-sectional wealth distribution. It has to be well-defined. Now, if the cross-sectional wealth distribution keeps on growing on the right tail, I don't have a well-defined object. So for this class of models, what I really need to do is make sure that people don't want to save, an unbounded amount. How do I get people not to want to save an unbounded amount? Well, concavity helps a lot. Because remember, anytime you're saving, you're not consuming today, right? So as long as my value function is starting to, really drop, the additions to future utility by saving are going to be outweighed by the losses you get today to your current utility. And that's going to be a natural thing that's going to bound naturally the wealth distribution. And so that's going to rest just on concavity. So, for existence and stuff, I think I need, this concavity assumption is going to be very important for existence. For the numbers that come out, I totally agree with you that they're going to be totally, it's going to be, yeah, no, but I think the really important thing for you guys to understand is that, we need concave preferences for this stuff to work. And that's pretty, I didn't have to put this and bounded, okay? I just wanted to do that for technical reasons. In fact, Huggett's paper doesn't have the boundedness assumption, okay? All right, so what's the endowment process going to be? Again, I'm just going to have people, there are two shocks, the support, you either are employed or you're unemployed. So E stands for employed, U stands for unemployed. The shocks are IID across agents, but there is persistence in this process. So I'm going to model your shocks come from a Markov a Markov process. And so again, this is just going to be a two-state Markov process. I'm going to normalize earnings to 1. So everything, when you see numbers on wealth in the model, it's just kind of, you would always go back and you would say, well, what's income in the world? Let's say it's 43,000. If the person has a wealth holding of 1, right, then they're holding 43,000. Their net worth is 43,000. Okay? That's how you can think about it. So I'm going to also have people, when they're unemployed, I'm not going to have a transfer scheme here. So I'm going to think of B as just, let's say, what they get in home production. But you could start to think about endogenizing a transfer scheme and getting B, and taxing the people when they're earning and transferring to people who are unemployed. It's just that's a simple constraint to add to the model. Okay, so the important thing is, in some sense, what the asset market structure is. Here, there's going to be a sequence of one-period non-contingent discount bonds. And then there's going to be this, this exogenous constraint, okay? And like I said, we're going to think about what the implications of this exogenous borrowing constraint are for the wealth distribution by varying it. And a deeper model would actually endogenize this. And if I get time at the end, I'll tell you how to do that. Okay, so just to keep our notation together. So, I'm going to enter into a period with a certain amount of assets. This is just going to be like a pure discount bond. So remember, a pure discount bond basically pays off 1 unit next period, and you pay a price Q for that today, right? And if the interest rate is positive, that Q is something, you're paying less for it today for the dollar tomorrow, right? Or not, I don't want to say the word dollar, for the unit of goods tomorrow. Okay, that's a pure discount bond. So when I get the interest rate, it's just an inverse of this price that we're going to solve for in the model. Again, because I said that there's no, there's going to be a continuum of agents, there's no aggregate shocks. Again, another thing that you would want to change in the model when you start to think about the world. And as we saw, there have been changes in the data between 98 and 2007 that you would want. This model, every single thing, the way I'm going to be, presenting this is going to be a steady state model. So everything I said in the data section, all these things when I said changes over time, where was it? Inequality over time, all these things in the model are zeros, right? In the model. So obviously that's not necessarily totally consistent with the data. Now, if these changes are on the order of 50% and stuff, then I really have a big problem, okay? And if the changes from in the previous version of these papers, the changes, from the early 90s to the late 90s weren't so sizable, and so, in that case, a sort of a steady state kind of analysis would be better, but definitely some things have changed. So that's a strong assumption to say that there's no aggregate, uncertainty that's moving these things around. Okay. Okay, but that's all I'm saying is there's no aggregate. So I have idiosyncratic uncertainty, a continuum of agents. We're going to apply the law of large numbers. And so basically there's no aggregate uncertainty, even though there's idiosyncratic uncertainty. And what we'll be looking for is a steady state equilibrium. So the price is then just going to be independent of time, right? Okay. I'm going to assume that the discount rate is less than the actual, discount bond price, and that's something that you would actually have to check, in equilibrium. Does anyone know? So suppose it was bigger. So another way to write this, Q. If I bring the Q over here, then 1 over Q is what? 1 plus the real interest rate, okay? So suppose that beta was bigger than Q. So then when I brought it over, beta times 1 plus R would be bigger than 1. Now, if you kind of just think simply about an Euler equation, that's basically saying that people would want to save forever. You'll never get a bounded distribution in that case. Now, in this case, even if, because there's this idiosyncratic uncertainty, what do people want to do relative to a world with complete markets? Save more, thank you. If they want to save more, what's going to happen to the price or the interest rate? The interest rate's typically going to be lower, right, than a world where there isn't this precautionary motive. So if I put beta times 1 over Q less than 1, that's consistent with, right, a model of precautionary savings because people are saving more and hence, the interest rate would be lower. Okay, so it's not, the only reason I'm bringing all that up is when I said something that must be verified in equilibrium, you might sit here for the next half an hour and say, he's got to verify it. It's not something to worry about. It's going to happen. Okay, it's natural. It's natural in a model of precautionary savings. Okay.
Just say that this is a necessary condition for the existence of a stationary equilibrium, since I know that well is divergent.
Yeah, that's all I'm saying.
Well, I'm not sure. It doesn't seem like you need to necessarily check.
Well, it doesn't happen.
I mean, you can prove that there's no equilibrium if this is true. So by finding equilibrium.
Yeah, I mean.
All right, anyway.
I'm trying to do this this is simple.
Pointless thing to say, sorry.
All right, so, and again, what I'm going to do in terms of the asset market structure is just take this exogenous borrowing constraint. All right, so let me just, again, be upfront about strong assumptions. I guess I should have added as well the assumption that there's no aggregate uncertainty. But we have exogenous earnings, we have exogenous borrowing constraints, we have no redistribution, and I really think people, there are papers that fix this, but that's they don't go all the way to fixing it. Okay, and I'll talk more about that later. Okay, so I have to parameterize this, and again, I want to say that I want to apologize for the simplicity of what I'm going to do in terms of the parameterization. But again, I want to just make this as simple as possible. Okay, you can do some very fancy econometrics to kind of get the right parameterization. But I'm going to do this simply. Okay, so I'm going to take a model period. So really, I only have, because of the normalization on earnings, I only have, I have that simple model. I mean, I really did. Actually, you know what I didn't add up here now that I see it. I'm kind of taking this as a parameter, okay? The borrowing constraint is a parameter, so I should have added that, okay? All right, but this is a very sparse, sort of sparsely parameterized model. So I'm going to use the replacement rate basically to match. So this set over, so these are preferences, these two, and then this is, in some sense, I'll think about this as being endowments. Okay, this is so I basically for these two preference parameters, these things are all going to be relative to a quarter. So I chose the preference beta preference parameter so that when the model, I put in beta of 0.994 as part of this is this parameter vector, that's what I called theta over here, right? So I put in a beta of 0.994 and I get out savings decision rules. I get out a cross-sectional distribution of wealth. I integrate across the cross-sectional distribution of wealth. And for a bond market, it has to be, the people who are borrowing are getting this stuff from people who are saving, so it's going to integrate out to zero. So at that beta, it's going to integrate out at a price that makes the market clear. So what I did was I put in a beta so that the market cleared at a 2% real interest rate. Okay? It's very, hopefully very simple and clear, right? Do people understand? So that's why it's not going to be a surprise. I just want to be upfront. When I match the data on real interest rates, you should say, well, that's not a surprise because you've actually targeted that. Okay? So that's not a test of the model. The utility function, again, I just take one of the simplest possible utility functions and I take a very low level of risk aversion. I could have calibrated the model to match other things by choosing this, but I'm just going to take this to basically be a little bit more concave than log preferences. Okay? I think this was one of the numbers that Lucas used this in his welfare calculations paper, but that's maybe why I took it, just to make calculations kind of similar. Okay, as I said, I normalized earnings, and then replacement rates, basically for the US, it's like 0.5. Again, this is a really simplistic way. In the real world, the replacement rate is time dependent, right? You don't get 0.5 as long. In this world, right, how long can people be unemployed? Forever, right? Very low probability of it, but they could be forever, right? So obviously, this is a strong assumption, right? That, in the data, you get a replacement rate for a certain number of periods, right? That's given by policy. So this is just a simplistic. On average, though, when I calibrate the rest of the process, what this model is going to say is you get the unemployment insurance on average. If you want to interpret this, because I'm saying the word replacement rate, that's sort of like unemployment insurance, that you would say on average like 2 quarters. Okay? That's what the parameterization is saying. Okay, so now I have to, the important thing, as I said, in my mind, the important thing is to kind of parameterize this mobility matrix, right? That's going to be exogenous, and then see how the model amplifies any inequality in the earnings process to get inequality in the wealth process, right? So so it's going to be very important what my earnings Markov matrix is. So I already right here, I've already pinned down the support of my earnings process, right? It's a pretty simplistic. It doesn't look anything like, remember, in the data. I mean, it's not going to be surprising. I should have a go-to. So, I mean, what does my earnings? This is what it is in the data. That's the earnings distribution in the data. What does the earnings distribution look like in my model? two points, right? That's all it is, right? So again, that's why I'm apologizing. It's a really simplistic model. Obviously, I'm going to want to, if you want to take this really seriously to match wealth inequality, you have to put in something that looks a little bit more like this. Okay, but I'm trying to keep it simple for you. Okay.
Earnings tend to dominate the capital income, so you still have the notes really appear in the income distribution as well. So you have income is going to include capital earnings.
Right.
Earnings, I think, is just labor income, right? Right. So once you look at the capital earnings in the model,
By the way, just as I should say as well, that earnings can include, when you say, I mean, you didn't say capital income, but for people who are entrepreneurs, it's not like, salaries, right? So that is a little bit different. But yeah, it's not a big, in the survey of consumer finances, they were about 10% of the population. But keep going, right?
Well, I guess I just mean that earnings is not necessarily two chunks if you include capital earnings.
Right. Okay, good. I think I know what you're now asking. So even though I have so this is a good question to make sure everybody understands what I'm doing. I'm sure you all do, so maybe I'm just, so there's a 2-point distribution here. I'm interpreting your question to say, well, what does the income histogram look like from the model, given that I'm putting in a 2-point distribution for earnings? So that's a good question. So what's the answer? He's already kind of said it, so I just want to make sure everybody understands what. Is it a 2-point? So one way to re-say it, is it a 2-point distribution here? Right? Because income, even if we take out the transfers, is equal to earnings plus interest on your assets. If you have a continuous distribution of interest of assets or wealth that we're going to have, I mean, to be honest, we put this on a computer, so it's discrete. It's a discrete grid. But if you have a big discrete grid of assets, then the R times A is going to be, in some sense continuous. So what I'm calling Y, which is earnings, plus the R times A, you can have something that looks like this, right, from the model. So that's a good question. People see that's, so even though I'm being really, really simplistic here, it doesn't preclude this part, okay? Yeah.
Kind of also in defense of the model too, like it depends on time scale.
Thank you.
Because the earnings data probably looks at earnings, annual earnings. So if you, from the model, say, let's define the time period to be like a weekly time period, and every week you can either be employed or unemployed, then basically you have an aggregation of 52 weeks of working from the model.
Right. So good. That's another. So I've calibrated the model to be quarterly. So it's, if we were to then measure, I mean, this stuff, as you're saying, I mean, this is like annual earnings. So I would have, given that I have 4 quarters in a given period, then what I was saying is that I have the earnings distribution for the quarter would be 2 points, right? But if it's measured as annual, it's going to be more points. But still, yeah, it's a small number, but that's a good point. Yeah. And you haven't seen this, so that's good. You're thinking. Okay, let me go back. Yeah, I know. Okay, so we're back to here. So now I've got to finish. That was a long-winded way of saying, what I'm putting in at the quarterly, the support of the earnings process, I'm putting in as 1 and B for quarterly. And then I have, remember, it's a 2-state Markov process, so the rows have to add up, so I only have to have parameterize 2 other things, pi EE and pi UU. So how am I going to get pi UU? I'm not going to go through this all that, I'm not going to go through the algebra. It's very simple algebra. But basically, if you have data on the duration of unemployment, okay, then the duration of unemployment, 1-to-1 pins down a probability of staying unemployed. Okay, so if I have a number here, I can pin down pi UU. For what I'm putting in, as I said, I'm putting in a little bit higher duration of unemployment than what is in the data, but I'm just going to say it's 2/4. In that case, the probability of remaining unemployed is 1/2. Okay, simple. Now, how about pinning down? Now I have to. I now have these. I have this one done. I have this one done, and this one done. I still have one left. How do I pin down that? Okay. So what I'm going to do is just use. Remember, this is steady state model. So it has to be the case that unemployment. The law of motion for what unemployment is has to replicate itself through time, right? So unemployment tomorrow is equal to unemployment, those people, the fraction of people who are unemployed tomorrow is equal to the fraction of people who are unemployed today and who stay unemployed, right? And it's also equal to the fraction of people who were employed last period, right? And who become unemployed, right? So that the way to read this is, remember this was like, this is S at time t, this is S at time t plus 1, okay? So again, so here's the employed people who become unemployed. Here's the unemployed people who remain unemployed. That's equal to the fraction of people who are unemployed next period. But it's a steady state model, so that number has to equal that number. So then you get a very simple expression for what pi UE is, right? That's a simple way to pin down the probability of entering unemployment. For our model, that pi UE is about 3%. So the probability of staying employed is 0.97, okay? Again, really too simplistic. I'm sorry, but I'm just trying to do it as simple as possible. So, so now I've got every parameter. I've got a number for every parameter. Now I have to solve the model, okay? The model is solved using 2 operators, okay? And I know the first operator you all have seen. Okay, so this is the most math you're going to see. Okay, so what is the operation? I'll call it like the dynamic programming operator. And solving this problem is going to give me all I want from this problem is a savings and borrowing decision rule. Okay, so people enter. So let's say what this. Let me say in words all this stuff. So there's this operator. I'll call it T. And it takes, this is the space of continuous, I'll call it continuous bounded functions on what are the states for a given person. Well, the states for a given person are whether they're employed or unemployed. They enter a period with some assets, and they're either employed or unemployed. Those are the states, okay? So again, they enter into a period. The notation here is that something with a prime is next period, okay? And something without a prime is this period. So I enter into a given period with a given amount of assets, and I get an earnings whether or not I'm working, okay? So that's the state, that's what this is the set of all possible earnings, states, and this is the set of all possible assets. And I'm looking for things, value functions, that are continuous and bounded, on this state space. And what this operator is saying is I take functions that are on that state space, and I map it into functions on that state space. Okay? That's what that's saying. Okay, everybody, I don't want to do a lot of math, but that's simple, kind of. Where is the mapping? I just want to make sure that people see the mapping into. So where's this function in? Well, let me let me say what this is, and then you can tell me the answer to that question. Okay, so here are those two. Here's in individual states, right? In competitive models, this is a competitive model. What do people take as given? Prices, okay? So here I'm taking as given a price, Q, okay? And what are they doing? Well, if you remember what the budget constraint, so if I write up the budget constraint for this, it would be, CT plus Q, remember that's given, is equal to Y ST plus AT, right? That's the budget constraint for this problem, right? So all I've done is substituted in what consumption is, right? If I take Q to this side, I've got consumption. So this is utility over consumption plus beta times there's exogenously my earnings may change next period. That's what that's taking into account. And the thing that I'm choosing is a savings function, so that'll tell me where I start with what amount of wealth next period I start with, okay? So the object I'm trying to find from this operator is basically I want the decision rule. That's what we see out in the world, are decision rules, okay? The value function is let me just keep going on here. I'm choosing my next period's wealth subject to, it's in a correspondence. This is called the constraint correspondence. And so my choice of next period's wealth is bounded by the borrowing constraint. That's what this is saying. It's also bound, just so that people remind me, what do you think, where did this part come from? What's that bounding? What? Well, let me say, if I rewrite, so all I'm asking is, where does this side of the inequality come from? If you rewrite that, that's just saying the consumption can't be negative, okay? So that forms what this constraint correspondence is. Okay, but the thing, when you actually put this on the computer, and you apply this operator, and this operator, by the way, is a contraction. This operator, what are you applying? When I said it's taking functions, continuous bounded functions into continuous bounded functions, how do I think about that? I just want to make sure everybody, because this is how you solve it on a computer, and I know you all know the answer to this, but so when I say it's taking continuous bounded functions, where do I see that here on this line? It's V. Which one? Is it this one or is it that one? Okay, so I'm mapping from these, right, into these, right? That's what we're saying. So, you start off, like when you put this on the computer, you start off with a guess, let's say, for what V is. What's a good continuous bounded function? 0. That's a continuous bounded function. Okay, so you could start with 0, apply the operator, and you get, because this is continuous and bounded, you'll get a continuous and bounded function. You keep applying that operator. The operator is a contraction. What does the V sequence? What is the V sequence? This is the stuff from Stokey and Lucas. It's should we play hangman? It starts with a C again. Cauchy sequence. Okay, it's in a complete metric space. It has the solution exists. Okay, all right. So when you get that, when you put that on the computer, it'll eventually you get. Just to say, because I'm giving you the code to do this, what you'll see on you actually don't see it, but you could comment out and you could actually see the value functions. What you would see is that the sequence of value functions are getting kind of closer and closer to each other. Okay. When you get to the end, which is that you've just gotten to a certain tolerance, that's in the code. You'll see something about value function tolerance. The end is when you're within that code tolerance. Then you have you can back out, right? Now I have the value function that solves this problem, and the decision rule that's consistent with that value function is the equilibrium decision rule, okay? So that's pretty simple, okay? That, I think, is like really standard for everybody. I don't know, for me, this is the harder part. And this is what we're interested in, is thinking about existence of the cross-sectional wealth distribution, okay? And this actually takes a lot more, you know, fancy math to kind of prove, to be perfectly frank. But I'm not going to go into that fancy math. I'm just going to give you the intuition for it, okay? Okay, as I said before, you know, if we all start off, you know, with the same asset holdings, depending upon our idiosyncratic shocks about, you know, whether we're employed or unemployed, our assets start to change, okay? So then the next question is, you know, so given that the asset holdings start to change, then I'm going to define this cross-sectional distribution. But, you know, the other way to think about it is, even if we start with different asset holdings, what happens when we get different earning shocks? Suppose you're a person that, I mean, it's going to turn out, and I'll give you a simple example. What do you think? A person that has high asset holdings, maybe the reason, why might be the reason why they have high asset holdings? I know you know the answer. A long string of positive employment, right? So then, because it's a precautionary savings model, they now have high assets, okay? Now all of a sudden they get unemployed. What are they going to do? So this is a person who's sitting out here in terms of, well, since you're on this side and you're looking this way, this is the right side of the distribution, this is high. What are they going to do? Just save. So then they're going to go down here in the wealth distribution. Now, there's a person with a very low number of assets. Why might they have a very low number of assets? A bad history of earning shocks. They're down here in the wealth distribution. They get employed. They might go to the very same asset holdings that the people who are unemployed. So that's kind of the mixing within the wealth distribution that's going on. Okay? Does everybody see that? And that, all this, so I'm going to think about that mixing. You know, what I was just doing is like an operation again. Okay? I'm going to apply an operator. I'll call that operator T star. Okay? And it's not a contraction. That's why I said you need fancy math. It's not as easy as the other one. But, you know, there are assumptions you have to make on the underlying problem in order to guarantee existence of that, the equilibrium cross-section invariant distribution, okay? And the other thing that's interesting is it is a, you know, the assumptions are such that you have a unique cross-sectional distribution, okay? So, you know, that's kind of good for thinking about doing, you know, policy experiments and stuff like that. You don't want it to be not unique. Okay, yeah.
I have a question about the asset market. Is the asset market exogenous in the sense that, like, any set of demands can be fulfilled by the government or some quasi-government agency, or are people trading assets within each other?
No. So they're trading assets among each other. So this is a lot harder to solve than one in which it's exogenous, because in the one in which it's exogenous, the price doesn't have to clear the market. The government would do all the clearing, right? So that's why this model, actually, one of the equilibrium objects that jumps out is the price, and that's what's going to have to clear the market, so that all the people saving and giving up funds has to equal the people borrowing. Yeah?
So it takes more to prove the existence of the equilibrium, but how do you come up with the actual distribution from the computation?
I'll show you. It's on probably the next slide. Okay. I mean, yeah. So now,
but then, if you actually come up with something, then why the existence problem is interesting?
If what?
If you can actually compute something, then why is it a big deal to prove that?
Well, yeah. So this is a really good. I love this question because I was at a conference one time, and it was between friends even. So Per Crucell said to Victor Rios' rule, you know, how do you know that that thing exists? And Victor had a bunch of computer code, and he picked up the computer code and he dropped it on the table and he said, it exists. Okay, and that's what you just said, right? Now, what if Victor had a typo in the code? What if he had a tolerance that was way too high and he said that the equilibrium existed when it didn't exist? So it's really nice. I mean, the only reason I'm going through all of this is because it's nice to know mathematically that the object exists. Okay, so that I think is a really good, so a lot of macro, and myself included, has been, picking up and dropping on a table. But I think it's really valuable when you have papers that actually do that, existence proof. Exactly. So it's very, I think the really good papers have both. Okay. All right. So now, but let me say what this operator is doing. So remember, when I kind of just did this stuff over here of saying, so this T star is what I was kind of saying is this, going like this and going like this and all that kind of stuff, right? Because what's happening is I'm going to take, again, I'm mapping, so let me say the word. So I've got this endogenous, remember, this is like a law of motion for wealth. That's what this function is, right? It says A prime is equal to G of S of A. So I have an endogenous sort of transition function for each person. And the shock process is also a transition function, right? And so, when if you actually were to simulate this thing, right, you could basically put in this exogenous thing, start off with a given A, and then simulate out what a person would be doing, right? That's one way to kind of do it. But this is not, I'm going to look for a fixed point of this process. And so what is the fixed point? This is going to be, I'm looking for a cross-sectional wealth and earnings distribution. So that distribution lies on the set of earnings, states that you can be in, and asset, the asset grid or whatever set. And then this over here is I'm just calling this like the set of all possible sets. So what we're doing is mapping these cross-sectional wealth distributions into cross-sectional wealth distributions. That's all it's saying, okay? Now how does that mapping work? Well, I take distributions. Remember, when I started putting people all over the place, I took distributions here, right? And I mix both the exogenous kind of, when I said, well, if the person becomes employed next period, they're going to borrow, or they're going to save. If they become unemployed, they're going to borrow. But whether they're employed or unemployed is exogenously given. How much they borrow and save, so where they move in the cross-sectional wealth distribution depends on the endogenous solution of your model. Okay? All right, so all this is saying is this one is just an indicator function saying, this person is moving. When I was having the people move to both from up and down to a given asset holding, it would just be what are the states that make them move to the given asset holdings, right? So, one was a person who had a lot of assets but became unemployed. They moved down potentially to the same place that a person who had few assets but became employed moved to. Okay, so it just puts them into a different bin of the distribution. Okay, and what we're looking for, remember, we're mapping a distribution last period into a distribution this period, and what I'm going to look for in an equilibrium is a fixed point of that mapping. That's what this is here, right? Mu prime is equal to T star mu. Okay, so I'm going to look for a fixed point of that. Okay? Let's see. Whoa. Okay, so here's the definition of an equilibrium. So this will help, answer the question that you asked. So a recursive steady state equilibrium, so it's an allocation, which is both consumption and savings, a price, and an invariant distribution, cross-sectional wealth distribution, such that for, taking prices as given, households solve their optimization problem. Given the cross-sectional wealth distribution, both the goods and the asset markets clear. So by Walras law, I'm going to focus on the bond market clearing condition. This is just the one that you were saying that, there's no government. It's actually equal to 0 here. And then I have to find this stationary probability measure, okay? All right. I'm going to, since I did this with my little, I don't know, I'm not going to go through this example, okay? Because I'm going to run out of time if I do. In the notes, you might want to take this example because it kind of gives you some intuition for what the mixing is in the wealth distribution. Okay, so existence of equilibrium. So remember, I have to do a few things. I have to, and actually, this is a good place to kind of say what's the algorithm. If you were to, suppose I was to do this just computationally and find it, right? So what would you do? In some sense, the most inside loop, and this is what you'll see in the program that you're going to get on the website, the most inside loop basically solves condition 1, okay? Because it's going to take a price and solve for decision rules, okay? Then the next step, once I have the decision rules, I can actually apply this operator, T star, right, and get the cross-sectional wealth distribution. That's like the next loop. And then the final loop would be I try to clear this market, right? Because I start with an arbitrary price. I get, decision rules for that arbitrary price. I get the cross-sectional wealth distribution or bond holdings for that price. I then check if the market clears. If the market doesn't clear, I put in a new price. Okay? That's a simple algorithm to solve for an equilibrium. Okay? All right. How do I know that the decision rule, exists and has nice properties? Well, I can just basically apply some theorems in Stokey and Lucas. Okay, I just want to say one quick thing that because you'll see it when I kind of say about existence in a second on the hard part. Basically what the decision rules, what you can show is that, the more as I increase A, right? So it's saying that the decision rule is strictly increasing in A, beyond the borrowing constraint. Okay, all that's saying is I do increase my, more assets. I save, basically provided I'm employed, but it doesn't say anything about the slope of that thing, and that's going to be important, and that's going to follow from concavity. So what we need to find this invariant distribution for mu star. There's a proof. I said the proof depends on certain conditions. Like mixing conditions on the earnings distribution. That's important. Let me kind of give you the intuition for this, okay? So remember, as I was saying before, you can't have the support, if the support of the distribution is forever getting, is forever changing, then it's not an invariant distribution, right? So eventually this thing has to, the support of the distribution has to, settle down, okay? I don't have problems on the bottom end because I have a borrowing constraint. The issue is on the top end, okay? So, if the important part of kind of thinking about existence of a cross-sectional wealth distribution, I can kind of show it to you in this picture, okay? So in this picture, here I've graphed the two decision rules. Remember, I just told you that the decision rules were increasing. So the more assets I have today, I have more assets tomorrow. It's increasing, okay? But what you can show is basically that when you're, so these are the two decision rules. These are not the ones, I'll show you the ones from the model. But this is the decision rule for a person who's unemployed. This is the decision rule for a person who's employed, okay? There's consistent with the theorem I said by Huggett that it's increasing, okay? Now, here's a 45-degree line. So the way I've pictured this, what's happening for a person who's unemployed, what are they doing? So this is what their assets are today, right? This is what their assets are today. This is what their assets would be tomorrow if they chose the same amount. What are they doing? They're actually choosing this amount. I don't know, can you see the little red dot? Okay, so this is what their assets are today. This is what they're choosing. This is what they would choose if they chose the same amount of assets they had today. So what are they doing? They're dissaving, basically, right? So the sort of decision rule for unemployed people is to dissave or borrow, okay? Let's take another one here. Let's take A2. This is what the person's assets are today, let's say. This is an employed person's decision rule. If they are employed and they have low assets, this is how much they choose of assets tomorrow. This is what it would be if they saved the same amount of assets. What are they doing? Saving. So all over here, for small levels of assets, they're saving. The way I've graphed it, the unemployed are borrowing. Okay? So the question is, these things are going forever, right? All I can prove is that the decision rules are increasing. But how do I know, basically, there's an invariant distribution? Okay, so let's go through a case. Let's suppose that I want you to think that there's an invariant distribution that lies between A lower bar and A upper bar. Okay? So suppose I started outside of A upper bar. What's going to happen? And just suppose that the person is, I'm going to do this sequence like the person's employed. Okay? Well, they choose, what are they doing here? They're dissaving. So then they arrive down here. Okay? I could do it again up here. I could, they could move to here. But the bottom line is, once they become, once they start to, they could either converge on this point, right, through a series of positive, earnings realizations, or maybe they get a negative earnings realization. Once they get a negative earnings realization, they come back into the set, and then they're always captured in here. Okay? So the bottom line is that the fact that the slope of the savings functions is less, it's increasing, but it's less than the 45-degree line, basically assures me that I'm going to have an invariant distribution. Okay? Now, what gets me that? The slope being, the theorem didn't say anything about the slope. Okay? But the idea, the intuition for the first theorem was something about that the savings functions were increasing, but it didn't say at what rate. But the bottom line is the reason for this is just really simple intuition. It's just the value functions, you know, after you have enough wealth, the benefit of saving a little bit more, what is it? I mean, it's a 1-for-1. If I save more, I decrease my consumption 1-for-1 with the amount that I save. But what's the additional value? If a value function is concave, what's happening to the additional value? It's decreasing, right? But there's a you know, a 1-for-1 decrease in your consumption. Your utility function is concave, but there's a big drop in your consumption in order to save more. So that benefit of saving more is offset by this big drop in your current consumption. Okay, that's the intuition for why.
Bounded too, so you have to argue which one's going to get flat first.
First, yeah. So that's where, you know, I literally put the utility function. If you know, putting this on a computer, that utility function is beyond the bound for that is beyond the bound of, you know, the precision of the computer. Okay. Now, one way, if you put it on, you know, literally the way you're saying, what you would find when you start putting this on the computer is that everybody's going to start, you know, kind of spike at a given high, you know, level because you've just bounded this thing, right? So that's you know, you can check that stuff is not going on.
This is under the assumption of a linear saving, right? A linear rate? Okay, because, I mean, that's key to this argument.
It's not key to existence. Okay, so let me say, just take a second to kind of say, so you could have, in the real world, interest rates depend upon the amount you borrow. Just take the easiest one, because I'm, you know, I don't know how many people own houses here. There's something called a jumbo mortgage. A jumbo mortgage right now is over $417,000. You check out what, you want to get a mortgage higher than $417,000, you pay a higher interest rate, okay? There is heterogeneity in interest rates, and it's a function of how much you borrow. That's exactly what you're saying. You know, you were saying it's linear. I just said that a nonlinear schedule for interest rates. And there's good economics behind why it should be, you know, a function of the number of assets you hold. If you're allowed to default, then, you know, the more you borrow, it's going to raise the likelihood of you defaulting. So an intermediary is going to definitely try to charge you more in order to, you know, get back possible losses of your default. So, you know, that's where, you know, in that kind of a world, which I totally think is in the real world, this is not the real world. This is like a pooling equilibrium, okay, where everybody faces the same price. The real world, there's separation along a lot of observable characteristics. So I actually know the answer to that problem because in that paper I was telling you about, we proved existence of equilibrium where there are these nonlinear schedules of you know, interest rates because there is a default option. So it's not the same proof, it's a lot harder proof actually, but it, you know, there's existence even with nonlinear schedules. Okay. All right. So I'm going to stop. So let's forget, I'm tired of existence. I should just do what Victor did and just, okay. So, but now I mean, I think what's important is thinking about, you know, people's welfare, okay? So since it's a structural model, we can start to think about people's welfare. So how do we calculate? I just want to make sure everybody knows how to calculate, because I'm giving you these consumption equivalents. I want to make sure you know how to calculate these consumption equivalents. So the consumption equivalents are basically going to be, we're going to get them through answering the following question. So we ask people, what fraction of consumption would a person who's in a given state, let's say this is their state of people in this model, of an incomplete markets environment, be willing to pay? So it's how much would they be willing to pay if this thing is positive, and how much would they have to be paid if it's negative, this consumption, what I'm going to call a consumption equivalent, in all future periods to achieve the utility associated with the counterfactual allocation that we're going to undertake. Okay? So here's, mathematically, that's what this thing is. Okay, so let me just kind of try to give you a little bit of intuition. So remember, if I wrote the sequential version of what a person's utility is in the incomplete markets model, it might look like something like this. Okay, it's just all this is the expected discounted utility, because here's the utility function, from a given consumption path, okay, starting in a given state. And I'm going to add these things called, these consumption equivalents, right? And that's how much the people would actually either have to be paid or have to, or be willing to pay to get to the allocation in the counterfactual that you're undertaking. Well, look, you can take out, this is the consumption equivalent in this particular, starting off in this given state. It's not where you're going. It's starting off today. You're asked that question today. How much would you who are in SA be willing to pay? Well, that thing, I can take that thing out. This is just what they're willing to pay today, and then this is going to evolve, but this is just conditional on today. I can just take that thing out and put it up to the front, okay? And then when I take that out and put it to the front, look, all this is, if this is out, and I have to kind of do some other things, but the bottom line is, this part here, without this, is just the value function from the original problem, okay? So what I do is, once I have the value function for the original problem, right, and I have, the value that you would be going to in the counterfactual, so I have this piece of this thing, I have this thing, so I can just solve this equation for the one thing I don't have, which is the consumption equivalent. Okay, so it's a simple algebra. Okay, so then what I need to do, I have one of these. I have this for every single person in this economy, right? In the cross-sectional wealth distribution. Each person, it's like you're asking each person, what would you be willing to pay or have to be paid? So now I have to integrate, in order to get for the entire economy, what do I have to do? I have it for each person in the wealth distribution. If I want a welfare measure for everyone, what do I have to do? Remind me? I basically have to integrate across the whole, using the distribution. I have one of these for each person. Then I have to, I did this for a discrete grid. I have to integrate across all, sum up over all the different people. Okay? That's going to give me the welfare. When I put down, a welfare calculation in the tables, that's what this is going to be. But I can also, once I have this, I can do some I can do lots of interesting things, okay? One of the things I could do is to actually just count the people who'd be, willing to pay, right? And once I count that number of people, that's kind of like if you put this all to a vote, if you had enough people, they'd accept it, right? That they'd want to move to the new thing, the new policy.
This is your median voter thing?
Well, this is much simpler than the median voter problem, but it's a flavor of it. Okay, we can talk about that later. Okay, but that's so you can actually kind of figure out how many people, if you just literally have each person say, here's what I want.
This is. What if you're writing a constitution?
that's a really interesting problem.
Because this is a very special form of utilitarianism. We have exposed realization.
Right. Right. I totally. Yeah. So something like, so remember I was saying that we did some stuff with this. So in the way that we were doing it, just to be clear about that, we did not vote over the form of the redistribution, which is another way to kind of say what you were saying in terms of the Constitution. All we were voting, I mean, yours is deeper. I'm just saying that if I had to, you know, kind of say it in those terms, for us, we were just voting over what the tax rate would be that would, you know, a median voter would choose. We weren't voting over the type of policy, which is the deepest type of policy, in my mind, would be a constitution.
Well, the only point was that Rawls would say that the assessment ought to be prior to even knowing your identity in the economy, which is the same thing as saying as before the initial realization.
Right. That's a different, yeah, okay.
Yeah, this just strikes me as an interesting thing to investigate.
Right.
Pushing a little bit harder, assuming the ideological voters, which apparently are going to this people found appealing, I might be interested in knowing that for my social welfare function, what I think society collectively ought to be willing to pay to achieve certain types of redistribution.
Right. I totally agree. But I think these are interesting questions. It's not outside of the realm to apply that to these. Yeah. Yep. I agree. I totally agree. So, you know, I'll just, because I'm going to run out of time. This stuff, you know, people, exactly what Stephen was talking about, you know, people have kind of, in varying degrees, kind of thought about this question about voting over constitutions and things like that in this kind of class of models. So the people that I think started, they didn't go as deeply as what Stephen is saying, but I kind of associate these kind of questions with some work by Per Crucell, Vincenzo Quadrini, and Victor Rios-Rull. They kind of wrote down a statement of a problem where it's called politico-economic recursive equilibrium. And so basically they're voting over certain policies, okay? And the deepest policy of which would be, you know, but they're using certain sets of preferences and things like that, but they're using it from a competitive standpoint. It's not the same, you know, what initial conditions we gave in that problem would be something that, you know, is another thing you could vote over. Okay. So in the last 45 minutes, I will kind of go through a couple of examples of how to use this, okay? So the first sort of counterfactual I want to think of, so, you know, in some sense I've calibrated the model to match what I think, so I'm kind of saying the world is an incomplete markets world. So then what I could do is ask the question, how much would people be willing to pay to go to complete markets? Okay? Now I calibrated it, so that's the reason why it's a counterfactual is I'm going to use the same parameters that from the incomplete markets world where I say this is the world. And I'm going to go, you know, I ask the counterfactual, what would you be willing to pay to go to the complete markets world? I mean, remember, in complete market, this is the reason why it's a counterfactual. Remind me, complete markets, what about consumption? So look out at the world. Is there consumption inequality? Okay. What's the allocation from a complete markets economy? How do people's consumption vary over time? I mean, in a complete markets economy, what happens? So that's why I'm calling. What? Yes. Or that's with identical preferences. Okay. So, you know, given that doesn't seem like the world. Okay, so that's why I'm going to call that the counterfactual. All right. So, you know, here I'm going to just kind of run through the complete markets allocation. That's really, really simple. You guys have all, you know, kind of done that before. All I have to do to get the complete markets allocation is just solve, you know, because we have complete markets, we have no, you know, everything's kind of perfect. The first and second welfare theorems hold. So I can just solve this as a planning problem. And, you know, so the planner is just maximizing, it's a utilitarian planner. It's just maximizing utility across the two states for people, subject to a resource constraint. That's, you know, that's where I get, you know, what Stephen was saying before about utility functions for people, you know, different utility functions might, you know, then you're going to have different multipliers, and if you have different multipliers, then you're going to have, you know, potentially differences in utility. In this world, you know, because we're assuming that, you know, the state of your utility only depends upon your consumption. It doesn't depend upon your state, you know, like your employed or unemployed state, which is a really strong assumption. You know, basically what the planner would say is whether or not you're unemployed or you're employed, you get the same consumption, right? That's what you know, that's not the world. That's not what happens in the model, right? The people in this incomplete markets model don't get the same consumption. I just want to make sure you don't think I'm kind of like trying to run something past you, right? People in this model that are unemployed are consuming less in the incomplete markets world. In the complete markets world, they're consuming the same amount. So, but then it's just really easy. So the thing that I had put, the allocation, what anybody would get in the complete markets world is just really simple. I can calculate this by hand almost, right? So that's the thing on this side. Remember, that's this. That's what they would get under complete markets. This is what basically they get with incomplete markets. So once I have this number, which I just got for you, I have this number from solving the problem, I can get the consumption equivalence. Okay? Okay, this just went through, I even said this already, how you would get the value function, how you would solve out, as an algorithm the problem that the incomplete markets world. Okay, so let me just say, let me just kind of run through a little bit of the properties of the incomplete markets world. So, you know, and I'm going to kind of talk about positive versus normative kind of things. So the first thing is basically the equilibrium, you know, we get an equilibrium bond price that was a 2%. That's not surprising. Again, I chose the beta in order to match this. So that's not that surprising. Here are the value functions from the problem. So if you're employed, here's your value function. It's lower if you're unemployed. Nothing that surprising. Here are the decision rules, and I don't know if you can actually see very well the decision rules. Remember how when I kind of said something about existence, I had this picture. These were just made up, the decision rules, but the key thing to note is that a person who's unemployed, it lies below the 45-degree line. A person who's employed, it slopes up less than the 45-degree line, starts above, okay, and ends up below. You're going to have to get out a microscope, but this little blue part is above. That's the employed guys. This is the unemployed guys. So it looks just like, you know, the picture I had before. I should have cut it off at like 2 or so, and then it would have blown it up a little bit. But
where do they intersect?
They intersect at, I can't remember, a credit level of A, but what I'm calling wealth in some sense, what I want to think of as wealth is both earnings plus A, because I'm kind of putting in the earnings, into a person's, checking account or something. So that would be considered their wealth. So the really wealth would be something more like 2. Okay, when I add, this is somewhere a little over 1, and this is, and then I add the other ones, so it would be around 2. That's why this point here, it's about 2, because this point here is where everybody is basically, if they have lots of positive, shocks, earnings shocks, then they're just piling up on that point. That point is not exogenous, it's endogenous to the model, okay? Does everybody understand the question and what we're just saying? Okay, so, remember, I mean, I don't know, this doesn't look exactly like, remember this thing? Remember this equilibrium object should have looked, just to be clear, I guess I shouldn't have done this. It should have looked like this, right? That's what, the thing that just came out of the model, this is what I would be comparing it to in the data, right? So, I'm just going to use a summary statistic to think about wealth inequality. So I can compute a Gini for this distribution, right? I can compute a Gini for this distribution, okay? And that's the thing that I'm going to be doing. I've got, way too many people, if you notice, on the, top of the distribution. Okay, that's one of the things that we get too much. People just want to save too much to avoid unemployment spells. Okay, the model generates a Lorenz curve. Okay, here's the Lorenz curve. As I said, the first quintile is actually negative here, and that's what it is, at least in the data that they had from Survey Consumer Finances. Okay, so now on to the normative stuff. I mean, if I just literally calculated, remember I said I could do by hand this calculation. So this calculation here, remember I have, this is a number, this is a number. This, what's mu? In this little example I said, mu was basically the fraction of people who were employed. So 1 minus mu is the unemployment rate. So what's this number? That's 5.66. This is 1 minus 5.66. Right? I know what beta is. I can compute that really simply. Remember, this is a CRRA preferences, so utility is it's negative. So now this is what I was calling, aggregate welfare measure. So again, this would just be if I literally take people's value functions and just integrate the value functions. That gives a measure. It's not surprising that that measure, this is more negative than this, so people would value the complete markets. But, what we could do is ask this kind of question the way that Lucas did, which is, what fraction of consumption would a person be willing to, in a steady state of the incomplete markets environment, be willing to pay in all future periods to achieve the allocation of complete markets environment. So there I just kind of calculate these consumption equivalents. So here are the consumption equivalents, right? So remember, here's 0. Right? So they'd be willing to pay, they like it. Over here, this is less than 0, they don't like it. Who doesn't like moving to complete markets? very wealthy people. They've already got, so remember, we've asked this question, we're in an economy. We're already in the economy. So it's not doing, this ex post, or this ex ante kind of behind a veil of ignorance kind of world. This is just kind of saying, I'm already in the economy. What if we move to complete markets? So the people that have already saved a lot, they're actually not that happy, right? The people who have very little assets and need insurance, they don't have enough assets, they're the ones that are happy, right? Now, where, so since there's like, this is people liking it, this is people not liking it, the aggregate number is going to get determined by what? I have to do what? I have to integrate using the endogenous measure. So, where that, so this is like if we took each of these this is for employed people, this is for unemployed people. Obviously, unemployed people like it more than employed people, right? Because they're getting the insurance. So what I have to do is for each of these, there's a cross-sectional wealth distribution contingent on your earnings, your employment status. I just integrate using that cross-sectional wealth distribution. Here's the cross-sectional wealth distribution. I didn't kind of say this well enough. The blue was employed people. The red here are the unemployed people, okay? Remember, I did this up to a given, I added, when I called this wealth, I added, so this is not on A, this is on, Y plus A, okay? So that's why it's bigger. But, I take this cross-sectional distribution and I, integrate with respect to that for the consumption equivalents for the people who are employed, and then I take the other one and do it for the unemployed, okay? And so not surprisingly, people who are unemployed, would prefer it. So I integrated across all the asset holdings and just got those who were unemployed, just got those who are employed. The unemployed would like it better than the employed. And when you integrate with respect to, both the measures of employed and unemployed people, you get a consumption equivalent of basically 0.2%, okay? That's not very big, okay? That's not all that surprising because, a bond market you can self-insure a lot through a bond market, right? So, one of the ways to interpret this experiment that I just did was to kind of say, we see the real world, we know there's not, there aren't complete markets in the real world. Why aren't there complete markets in the real world? Well, if it's costly to start up a market and there's not a big gain, 0.2%, if the costs of actually starting an exchange or whatever exceed the benefits, you're not going to see it, right? So it's kind of like this is kind of a rationalization almost for why you might see incomplete markets in the real world. That's what I was, trying to do with this example.
That's not really the answer to the dynamic with finance guys, but
well, why there's, the
information and moral hazard, things like that.
Right. So this model does not have moral hazard in it or anything like that, right? But if it's really impossible to tell, the new dynamic public finance guys would say, remember I started this off by saying that there are not insurance markets against backaches, right? The backache is like a moral hazard problem. So, the way that you would solve it in that class of models is to basically say that, people make reports about whether or not they're backaches. If they make enough reports that they're backaches, then you start to punish them, right? and that's through future promised utility in that class of models. But that's like saying I use different taxes. The punishing is I use different taxes and transfers. First time they say I have a backache, you give them a transfer. Then you make their promised utility go down. So this doesn't have backaches. It's like they can't make reports here. So the only incentive compatible thing would not be to make transfers contingent on your messages. I don't know. I don't see that the government is saying to the, or people are saying to the government, my back aches. I don't know. So that's the way that this class of models doesn't do.
I'm sure so. This class of people are not saying to the government for back aches.
Yeah, I'm saying this model, suppose you had a model where it's impossible to send those messages, okay, that my back aches. Then you can't solve basically the dynamic, that problem that's at the basis of the new dynamic public finance is, these are papers by like Spear and Srivastava were sort of some of the first ones to do it. And then that's where you make messages about what what you did. And the way that the contract works is to basically spread out via promised future utility and transfers today what's going to happen. And all I'm saying is, suppose that you had a world where you couldn't send messages. Then you can't condition, these kind of promises on that. Or you couldn't remember the message the government couldn't keep track of your messages. Then you couldn't actually implement that kind of a contract. That would be closer to this. Okay? Okay. The only other thing I'll just mention quickly is if you tighten the borrowing constraint, remember what happens if you tighten a borrowing constraint? What do people want to do? Remind me, I forgot. After you guys are getting tired, I'm getting tired. It's like 3.5 hours. Let's say I forgot. Save more, thank you. So what has to happen to the interest rate? It has to drop. It actually can drop negative. I want to ask you, what do you think the interest rate is in the US right now? The real interest rate? I mean, for very, for certain, very safe. So I can tell you, my checking account, I'm getting like 1/100% or something. It's something crazy. What's the inflation rate? Is it 1/100%? It's higher than that. So what's my real interest rate? It's negative. Okay. Okay, that's all I want to. The constraint. And tightening the constraint makes people worse off. That's pretty clear. Interest rates. It's doing it to both sides. Interest rates are getting, are making the savers worse off too. I feel like I missed. Well, I feel like I went too far beyond something. So anyway, that I'm now doing the welfare cost of tighter borrowing constraints. Somehow I feel like I'm missing a slide here. Well, let's start here. So in the recent financial crisis, lenders have tightened borrowing constraints. What happens if the borrowing limit is cut in half? So precautionary savings rise, interest rates fall, real interest rates can become negative. And for saying that I'm going to cut the borrowing constraint in half, to get rid of that, basically people would only be willing to pay up to 0.2% to do that. That's where this number comes into play. Here all I'm showing you is what happens to the. These are the benchmarked cross-sectional distributions. This is for the unemployed people. This is for the employed people. You see the unemployed people. Most of the unemployed people are banging up against their borrowing constraint, right? These are the wealth distributions for this is for the unemployed and this is for the employed. Remember what I said, that the number, the upper tail is endogenous, right? Why is this number, just let me make sure that you guys understand. Notice this is the benchmark economy. This is the economy, there's lots of people at a low, bunching up, right, at a lower level of wealth from than they were before. Remind me for that, why, if they're employed? I'm getting tired again. You have to remind me. Well, if interest rates fall, saving is not as good a thing, so I don't endogenously want to save as much, okay? And it's this kind of, look, the employed people are over 95% of the population, right? Or no, 94% of the population, over 94% of the population. So it's what happens to these people that when you start, integrating their consumption equivalents, it's going to have a big impact, and it's also going to have a big impact on the Gini, right? You see that the wealth distribution is becoming more compressed for that reason, okay? And that's also kind of why. Here's the wealth Gini. Remember, I said what's going to happen to the wealth Gini? So because the distribution becomes kind of more compressed, the Gini falls. Okay. All right, so now what happens if we raise unemployment spells? Okay, so the way I'm going to think about raising unemployment spells, I'm just going to do a really simple thing. All I'm going to do is take the duration of unemployment and I'm going to double it. So it's going to go from 2 quarters to 1 year. Okay, simple experiment. Okay, so that simple experiment actually changes 2 things in sort of the calibration in some sense. Why is that? Remind me. So let's go back. I'll here. So all I'm doing in this experiment now is changing, here's the duration. I started with 2 quarters. Now I'm going to put in 4 quarters. And I'm going to just kind of think of this as being just just unanticipated to start with, okay? So in that case, if this goes up to 4, pi UU has to change, right? This is going up. So pi UU, the probability of staying unemployed has to, that number has to go up, right? This goes up. With a minus, it goes down. It's on the denominator, so that makes it go up, right? So pi UU actually switches to 0.75. Now, once I have a higher probability of unemployment, once I put it into this equation, that means that, for anybody that was unemployed before, now there's more of a likelihood that I'm going to be unemployed, so the unemployment rate's going to grow as well, okay? So I just wanted to kind of, that's why when I look at this, so I raised the probability of staying unemployed to a year from 2 quarters. And that's also why the unemployment rate I'm thinking of this as a counterfactual now. That's why the unemployment rate rises to 10.71%. Now, obviously that's not what it is right now. It's in the 8s or whatever. But that's kind of a flavor of what's happening, in the current crisis. So that's why I was saying before, it's almost like it's unanticipated. I didn't think this was all going to happen. And then all of a sudden, both the duration spells and the unemployment rate rises. This rises too much, with this calibration, but that's the one that...
I think, though, that reflects the real unemployment. I think that number is almost exactly the same as the real unemployment.
Oh, really? Oh, that's good. You mean like people that have not left the labor force and stuff like... Yeah. Okay, that's a better model than I thought, yeah. Okay, so again, think about the model. With the model, you know, all of a sudden, I have a longer spell of being unemployed. When I'm unemployed, what do I do? Remind me of what the decision rules say. I heard it, dissave, right? So, because, you know, I want a consumption smooth, right? But in order to, you know, have enough to dissave to keep my consumption smooth, I have to save a lot, right? So in the steady state, people want to save a lot. I mean, that's also something that if you think about the current, you know, crisis, people are not spending enough. I mean, that's what everybody says. People aren't spending enough, but that's because they're saving. You know, savings have risen as a consequence, you know, relative to the benchmark of what was going on before. So, but what happens then, you know, well, if people are saving more, then real interest rates drop, okay? In this case, they don't get negative like they are right now, but real interest rates are dropping, okay? You know, and so what happens in the model, what happens to the wealth genie? Well, you know, the wealth genie goes up. So you do see more inequality, right? And that's because you have these longer spells of unemployment, okay? And, you know, people are trying to save more, and they're also drawing down more because they're unemployed longer. Okay, this has, you know, in terms of welfare consequences, you know, this is kind of huge, right? Because this is kind of now, remember, the moving to complete markets is 1/10 of 1%. You know, relaxing borrowing constraints is 2/10 of 1%. Sort of getting rid of these long spells of the duration of unemployment, it's really, you know, people really want that. Okay, that's what this is. You know, 3% of your consumption, to be willing to pay 3% of your consumption would be, you know, that's a huge number. Again, these are all sort of simplistic calculations. I mean, if I took a higher coefficient of relative risk aversion, what's going to happen to these numbers? Just remind me. I took a really low one because I didn't want to, you know, people saying, oh, God, that's because you took such a high. But I took a real low one. If I raise the coefficient of relative risk aversion, these consumption equivalents are going to rise tremendously. Right?
Does the aggregate endowment change?
Yes. So that's another, so there's two, that's a very good point. The aggregate endowment, once this changed, right, the unemployment rate, where do I have it? Right here? In terms of the resource constraint for this economy, right, it's back to, this is the resource constraint. Whoops, not there. This is the resource constraint. So this is like the market clearing condition, the goods market clearing condition, right? And when I changed the duration of unemployment, that changed these weights. And so you're right, there's like it's kind of like you would want to kind of, what I could do on a counterfactual, the right counterfactual, it's a very good question, is to really get at this stuff, it's a mixture. I mean, let me just say, I didn't do the wrong counterfactual, but the one that you want is to say, what if we were to keep the level of output? This is kind of mixing both a level of output effect with, you know, a consumption smoothing, an insurance kind of benefit, right? And this does both, but I can easily do a counterfactual because I have a model. I could do the counterfactual you want and then disentangle how much is it due to the kind of level effect and how much is it due to the you know, the smoothing effect.
So you're saying sort of the proximity to the first best or something?
You mean through the level? So the first best is it's still going to happen in the first best if unemployment all of a sudden rises.
It's in the first best too, right? Because coming down. So I guess you say, like, if the first best welfare went down by, say, 3%, like the residual is because of the...
Yeah, but that's in the, you see that, let's talk about that. That's in the context of the complete markets model, and that I don't think is the right comparison. So what I was kind of trying to do was disentangle what you want to disentangle by not having to use the first best, because that's really not part of the counterfactual. The counterfactual is between two incomplete markets worlds. Okay, but that's a really good, that's a good point. These are what's happening to the distributions in this economy. So this is, I was kind of interpreting this, so the way I kind of calculated things there was literally to say, again, the point that Stephen made was really a good one, and so the different types of, the different questions you pose have an implication for what the welfare results are, right? So I'm actually, the way I'm kind of thinking about posing these questions in the context of this model is where we're actually in an equilibrium, the benchmark, that's how I calibrated the thing, and we're in this, the steady state of an incomplete markets economy. So there is already a cross-sectional wealth distribution. So then the issue is when I say, what would you be willing to pay? I'm asking each person, not before, but in that world, sort of ex post, what they'd be willing to pay to go to the next one, okay? Now, so that's why I use the cross-sectional wealth distribution when getting the aggregate number. But the other thing that, this simple kind of thing doesn't kind of get at is that if I knew, right, the way that this kind of is being done, I'm kind of comparing these two steady states. That's not really the right thing to do. Because if I'm already in, I'm in this steady state today, and then things change, it's potentially going to take some time to get to the new steady state. And on that path to the new steady state, interest rates are going to be changing, right? Because remember, in this particular example, I'm surprised by the high duration of unemployment. And since I'm surprised about that, I didn't save enough in anticipation of the new unemployment spell, right? So that, that has a big impact on welfare calculations. So really the right thing to do is to calculate these transition paths, okay? And so, that's what this is about. And so here are, the transition paths. So, as I was kind of saying before, if I get surprised, now all of a sudden, all the people who are employed really want to save a lot. I don't know if you can see it, but so these are all 10 to the minus, 3. So here, the original interest rate is somewhere around here. The steady state interest rate for the new economy is somewhere over here. Okay, it's a little bit lower. But what happens immediately is everybody really wants to save. So you get this, this really, this big jump in, or drop in real interest rates associated with everybody wanting to save, okay? That's going to have implications for the people that are saving in the first place, and hence it's going to have implications for welfare, okay? So I don't want to, belabor this stuff. This is what's happening to the Gini. This is just Gini coefficient in the transition. Remember, we said the Gini's rise, there's more inequality. There's not as much inequality at first, but then there's more. Okay, so that's, let me Yeah.
Has there been any investigation of models of multiple goods and multiple types of marketing completeness? The reason I'm asking that is these classical results of Oliver Hart, in which equilibrium are not Pareto optimal. And furthermore, adding a market could lead to what Pareto decline.
Yeah, so that's I think that's really interesting. There's work on that. So some
other examples of the second, in which you start with an incomplete markets model, add a market, and everybody's works well.
Yeah. So
who's done it?
I mean, I have an example in stuff that I've done. Okay, yeah. In fact, I can kind of give you a flavor of that right today. Okay, so I just want to kind of briefly, remember I said there's directions for future research. So that was the simplest possible model. It's been around for, the quantitative versions have been around for 20 years. So I just wanted to kind of take that simple example. So there were all these things that we'd want to do differently, right? So the first thing I'll just kind of say is thinking about endogenous borrowing constraints. So what I think is a really interesting part of this is relaxing the commitment examples. As I said before, I think the stuff that Kehoe and Levine did, and Narayana Kocherlakota, it's a lot about what's gone on with the whole new dynamic public finance. All these models are a little bit along that dimension. The new dynamic public finance is typically private information problems, but it generates, in some sense, endogenous constraints. And these use commitment problems as a way to endogenize constraints. I think this is really interesting and really important work. Okay, the paper by Kehoe and Levine is brilliant. It's a great paper. But in some sense, so it's what questions do you want to use the model to answer? I don't think you necessarily want to use that model to answer questions about bankruptcy, for instance. Okay, there is a class of models that do that. I'm just taking an example I know a lot about. So we did it. And in that model, you do get that equilibrium default happens in the low earning states. There are endogenous borrowing constraints. In our stuff, the endogenous borrowing constraint actually depends upon legal institutions like Chapter 7 law. I mean, the one other thing I didn't tell you about the Chapter 7 stuff was, if you go Chapter 7 bankrupt, it stays on your credit record for 10 years. And then it's wiped clean by the Fair Credit Reporting Act. Okay? Now, and this is going to get to the question you were asking. It's almost like, in this model, in this class of models, there are multiple restrictions on the environment. So one of them is that there is literally exogenous incompleteness in the form of, let's say, bond contracts. The amount of time that can be kept on, that can be kept on your record, the default can be kept on your record, it's almost like a restriction by the government that it has to go off after 10 years, okay? So that's the multiple forms of frictions in that class of models that, if I can get rid of one friction and I'm still, it's like, that's the third best. If I get rid of one friction, I'm still in a second best and welfare can get worse, okay? That's one sort of way to kind of think about it. And
then you're understating the value of what you did, because the hard idea essentially at a market operation exchanges prices in a way that reduces monopoly power. But we were showing is something that speaks very much to one of the issues of the adding of these complicated financial markets, which is the information structure shift that may have had certain consequences.
Right. Yeah, no, I agree. You can also do, so I like kind of saying, what can you use these models to do with, answer policy questions? This paper took us probably about 6 or 7 years to write. Okay, we started writing it before, when it was in the in front of Congress. They were going to change the bankruptcy law to say people with above median income cannot file for Chapter 7 bankruptcy. That was a major change of the bankruptcy law in 2006. And we started writing this paper way before that. So we thought we were going to have this clever counterfactual that would say a lot of things. It turned out that the policy got done, before we finished writing the paper. But anyway, you can show it has a major impact. Okay, so and it comes a lot through, what it does to interest rates, right? The general equilibrium kind of part of this. It's very important, because if these people can't default, right, then there's less risk. So interest rates tend to be lower, and that helps borrowers. And it's really the borrowers. If you think about what a utility, a concave value function, it's really the people at low points that is generating a lot of the welfare gains, because that's where it's very, very concave. So it's whatever you do to help the poor people helps a lot. So that 1.6% of consumption. And this I was a lot more confident in how we had a much more complicated model than what I've been showing you. So I kind of feel more confident in the parameterization of that model than what I was showing you. Yeah.
Could we affect so we even in reality, considering what you said, that most people that go bankrupt are not reached?
Yeah, so that's why
even with a low mass of people that you prevent from being bankrupt, that would have so big effect.
Yeah, I mean we calibrated the model to match exactly the data. So I shouldn't to match exactly. I mean, I'll take. I mean, it was close. We're very close. Okay, so one of the things. So there's an interesting question actually when you think about it. So in the data, if you look at people that have a Chapter 7 bankruptcy on their record, they don't get. They tend to get very little. They don't get to borrow much, at least for the time that the bankruptcy is on your record. Okay, it's in the data. So the question is why? I mean, let me tell you a little bit more of. I know this sounds like a stupid question, okay, but just when you think about it a little bit, it's actually. If I remember correctly, Rob Townsend, who I think is one of the most brilliant people I've ever met, Victor was presenting this paper, and Rob said, so what did we do in this paper? We basically, to make our life simple, we had the bankruptcy flag on be a Markov process, and we calibrated it so that on average, people's bankruptcy flag left after 10 years, which is what the Fair Credit Reporting Act says. That means, remember, that some people are going to have that flag removed next period, low probability, right? But on average, it'll be 10. Some people will never. And so that actually is kind of, it was a nice way to do it because it lets people get access to credit, in not that much time, and then some people don't get access to credit for a long time. That actually is more consistent with the data than just that kind of step function if we literally kept 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? So, but what the assumption we made was during that time, you don't get to borrow, okay? So there's Rob Townsend asked Victor, why? Why don't people get to borrow? We just assumed it, right? They can't, by the way, law says if you go Chapter 7 bankrupt, you can't go bankrupt again for another 5 years. You can't declare Chapter 7 bankruptcy for another 5 years, okay? So it actually seems like they're a good bet, right? So the question is why, okay? So what we did, there's a different paper that we've been working on this about the same number of years. And we just finally finished an existence proof for this. And this was a much harder existence problem. What we did, because this is an adverse selection environment. So we said that the reason why people, don't get credit is maybe what their credit market behavior basically is a signal about something that's unobservable about their type, okay? And then what we did was, given that their type is actually unobservable, you could ask the question, well, if I'm a lender, how do I get an assessment about what your type is? So what we did with the model was to say, conditional on on a history of asset market behavior and bankruptcy flags, what is the, what's the likelihood this guy is of a given type? And that's your type is a function, influences whether or not you default. What's a credit score? Does anybody know what a credit score is? So a credit score is basically like the probability based upon your history of credit, market behavior, the probability that you're going to default on, some contract. So what we did was that posterior that we were having the intermediary form, we kind of can think of that as a credit score or an input into a credit score, right? Now that's the reason why it's taking us even longer than the other one to do an existence proof. Now you have another equilibrium object that affects prices, and this belief function, you have to find a fixed point of that. It's a huge nested fixed point problem. And proving existence of that is hard. It was a whole different, we had to apply Schauder's fixed point theorem instead of Brouwer's, all this kind of stuff. So, but the bottom line is, then you're actually able to answer questions. There were two parts to that. In the real world, the people have to get rid of the bankruptcy. The government says it's gone after 10 years. So then you could answer questions like, even though there's incomplete markets, what happens if we extend? You would think that extending information, the amount of time that is on your record. By the way, our adverse selection, I should tell you, is kind of it's a much more, it nests a different type of, what you might think of as the standard adverse selection problem. We allow a person's type, which is unobservable, to be a slow-moving Markov process. So you can be, so what would be the standard typical adverse selection model? You're always a good or a bad type. Here we let you be, a good type for a really long time, or whatever. Okay, so you do cycle in between that, but getting rid of this information after a certain amount of time, provides. It's kind of like the question. It's getting rid of it is, provides some insurance to people who have had shocks that competitive intermediaries would want to use when they're pricing things. Okay, so it actually turns out. So when I say, we find the economy is actually slightly better off with the restriction, and that's conditional on the calibration of the model too. So I don't know whether this is, but this is calibrated to the U.S. data. And so, this is kind of like saying we're still in a second best world because we still have incomplete markets and stuff, but we're adding more information and finding that, that. No, I'm not applying. Right. Right. Exactly. Yeah. I mean, it's exactly right. Yeah. The paper has reference to Riley's stuff and Hart's stuff, which is exactly the stuff. Yeah. So it's a good example of what Stephen was asking. Okay. So we're over time. Let me just say two other things that, like I said, I think that this, it's very easy. If you're at all interested in this class of models, I took the simplest possible one, but people were even asking me, I can't remember who it was during the break, it's very easy to make this into a life cycle model. That's more consistent with the data. The reason why it's easy to do that is, the contraction, it's a finite problem. I mean, I know a solution basically exists to that. So, that you can do that pretty simply. I'm sure that Lance probably, talked about the paper that he did, but this would be an example of how you could endogenize earnings. It would have borrowing constraints, and it's in a life cycle model. It's very simple to do. And the stuff, changes in the extent of GSL. When he said underlying private lending, they were actually using the possibility that people can default. I think that that's one of the interesting things to be working on right now. I mean, it's in the news, right, about student loans. and the being able to finance these things. So I think that's an important problem that you can use this class of models to kind of think about. And then the last thing would just be we don't have time. I would have talked a little bit about this dynamic political economy model that we've kind of thought a little bit about how to apply that. I just think that the only reason I bring this up is not because I think, I just think it's an interesting question. We've got an incomplete markets world. There's, people are not, it's not perfect. So government has a role. And then once government has a role, I think it's very important to endogenize government. And then, so how do you endogenize government? Well, what a lot of people do is actually just, have the government be a social planner and choose the policies in a restricted class of policies to maximize, the wealth, the equal weighted relative to their distribution utilities of people. But, I don't think that's necessarily going to be the right way to do it. I really think it would be good. I'm not saying, it's very hard. Take my word for it, it's very hard because you also, most policies are not, sort of, all these median voter models, there's not a lot to be able to be said when you're in multiple dimensions. So, you have to be very careful about that. The types of policies, you can only answer, questions. We answer questions in a very restricted set of policies so that we really only we can kind of employ single peakness of preferences and stuff. But I think that's a really interesting, I would really, say as in the future, thinking about political economy in this class of models, where you have an endogenous distribution is actually very, very important. So that's a challenge. I mean, I really think for some of the reasons that Stephen brought up, I mean, that's a challenge for future research, okay? But I think it's important to endogenize it because in the real world, government, this is endogenous. Okay, so that's it.